Okay, hello year 7. Welcome back. It's Computing with Mr. Ali. So, first thing we have is a couple of updates. Hopefully, last week we had our audio syncing with our video. Hopefully today it will be too. We'll see. Secondly, ostensibly, as you'll see from your tier 2 keyword, we will be moving to live lessons next week. We will be covering different material. It won't be programming. The department's decided that programming is difficult to teach live online on the internet, so I may still continue to put these videos up for you to watch, for you to learn from. But next week it will be live lessons, I believe, on Tuesday mornings. So watch for an announcement on that. Now, without further ado, we're going to move into our RoboMind Academy, and we're going to see what kind of programming we have set for today. Now, last week, I asked you to create a staircase like so, create some code so that Robo the robot created a staircase that came up here and intersected with the white line at the top. For our next task, what we want to do is get Robo the robot to paint the floor. In this case, we want him to paint vertical stripes, and you can see up here I have some, it would be done in this way, and above there is some code that I have done already. Now, here it says adjust all the ones to get it right. The sequence numbers and the iteration numbers will all be at 1. So paint the floor forward 1, backward 1, forward 1, repeat 1. I've adjusted this so that it will work correctly to paint vertical stripes. What our goal will be is to not just paint vertical stripes, but to also paint horizontal stripes. Now, in this case, Robo is going to go all the way up, paint a stripe, come all the way back, turn, go up this way. Now, there's probably a better way to do it with less mileage on Robo, but it will take more lines of code. So there's always a trade-off between the number of code and the efficiency of the output that you get from the code. You have to always think in terms of the algorithmic output. Code efficiency is a goal, but also the efficiency of the actual output task and the output function. I should rephrase that. The output of what you want to accomplish is a goal as well. So if we see here in this task, we have Robo, who's a robot. He'll have mechanical parts and gears and whatnot that will have wear and tear as he goes up and down. There's paint that gets painted on the floor. That has a cost. And there's lines of code that have a cost. If you have a software developer or programmer, write these lines of code. The question to ask yourself is it more efficient to write more code and have the robot do less work? Is it more efficient to write less code and have the robot perhaps go up, come all the way back down, go over, paint up, come all the way back down, etc.? That's a question that you will face in your careers. It's a question you may face with people that work for you. But in computational thinking, these are trade-offs and cost-benefit analysis that you will do to work out the absolute best of all the different variables that you have to work with. Okay, so what we've got here, I've painted him white. He goes forward, comes back, turns, paints all the way up again, and we've got vertical stripes. Yay, awesome, dude, as it says. Let's go to the next screen, and what we want Robo to do is paint, scroll back in, paint horizontal stripes. And again, this is one I created earlier. So as he paints away, we'll see that he goes and goes and goes. Now, if you look up at the code, you'll see you still got to repeat 6. You still got to paint white. You still got a forward 5. You got a backward 5. But instead of going straight, first he turns right. Then he paints white. stops painting, comes backward 5. So it's very, very similar code. This is something very similar to what in many programming languages you might call a function, a method, or a subroutine. And what these are chunks of code that you can write, and then it can be reused in another place. So you get code efficiency by writing once, running it many times. The coding language Java was meant to do this. It never quite managed that, but it was called worm code. Write once, run many times, as it was meant to run on Windows, on Linux, on Unix, and on different platforms, so that you only had to write one program, it would run everywhere. That was the idea. What we can do with higher level language codes, from C to Visual Basic, in some cases to Python, in many cases, is to write a chunk of code, and then that chunk of code, in Python is called a function, and in other languages is called other things. It can be run other places. So we'll look at that in just a moment. So here we've had Robo write vertical lines across the page. It's painted vertical lines across the floor. And the next thing we want to do is combine the two. So if you come here, you can see I've got two sequences of code. I've got repeat 3 times. Here's my sequence. My iteration is 3 times. I've got another sequence, similar but not the same, and it repeats 3 times. See what happens when we get that. And the idea is that down below, we want to have the floor look like this at the end. Now, as you can see, as I was saying before, an efficient way of painting might be to paint vertical lines and then paint horizontal lines. It might be to paint a circle around the area and then put crosshatch lines in between. Who knows? That depends on the use case. Depends on how expensive your paint is. Depends on how much runtime your robot has. But as we saw from the illustration from the video at the Ocado warehouse, these are very useful bits of code and controller programs that can be used in real-life situations. Okay, now, the sharp-eyed amongst you would see that down here, when Robo hit this corner, he went left, forward to left, and had a few extra unnecessary movements. However, again, to keep this code at these number of lines, rather than essentially doubling or trebling the number of lines, it was a fair trade-off. So those 3 lines saved writing about 25 other lines of code, and all it did is had a couple of extra seconds of unnecessary movement. And there we go. We've got a nice checkerboard there at the end. That's the way. Okay, so what I would like you to do is work through these, do these yourselves. You can see my code that I used in the video. And then the next task is to do the same thing, but on a much larger board. Let's see if you can accomplish that. Tweak the code that we have here, get it to paint on a much larger board, screen grab that, put it into a Word document, share it with me on OneDrive. If you can do that, there are hub points and golden tickets in it for you, and I look forward to hearing from you online. Thanks very much. Cheers. Bye-bye.